Hi there, and welcome to another Papetti Math YouTube video tutorial where I'm going to be teaching you, yes, you, Algebra 1. And we are going to continue on our lesson where we deal with causation versus correlation. This video specifically is going to talk about correlation coefficients, what they are, what they measure, and why they're useful. So if we take a look at the top of this screen right here where it says, correlation coefficients are used in statistics to determine how strong a relationship is between two variables and how reliable a regression would be with that relationship. A correlation could be classified as strong, moderate, or weak, as well as positive or negative. The strongest negative correlation is R equals -1, and the strongest positive correlation is R equals 1. So at this point, any set of points could give you a linear regression equation, but how useful that regression equation would be is totally up to the R value, because those points might be scattered so far around that it's not an accurate line that goes through them, or they could be a set of points in a perfect line. And that would be the case of an R equals 1 value, where it's a perfect linear relationship. And that linear regression equation would be the perfect fit for that data. So in exercise number 2, we have a table. And for each of these tables, we're going to graph the scatter plot. And then we're going to use our calculators to find the correlation coefficient using the linear regression function in the calculator. Okay, so first let's start off by graphing this set of 5 points right here. We have the points 2, 2, so we'll graph that point right there. We have 4, 5. We've got 6, 6. We've got 8, 8. And we've got 9, 8. So just by looking at that scatter plot right there, it does look like those points are very tightly packed together if you were to make a line of best fit. They're not scattered all around the graph. They are in a general pattern. So the next thing we want to do is we want to go to our graphing calculator. We're going to go back to our favorite button in this chapter, Stat, for our chapter 12 on statistics. And we're going to edit our lists. Anything you have in your lists already, you could go ahead and clear out of that list. And what you're going to put in list 1 are your 5 x values of 2, 4, 6, 8, and 9. 2, 4, 6, 8, and 9. And you're going to line up your y values with each x value of 2, 5, 6, 8, and 8. 2, 5, 6, 8, and 8. Now that we have that, we're going to go to our linear regression. So remember, we go to Stat, over to Calc, and we're going to go down to choice 4, which is linear regression. What we've seen so far is something that looks like this. But there's a way to get additional information regarding this linear regression equation, and I'm going to show you how to do that right now. So what you want to do in your calculator is you want to go to the catalog, and you can find that by looking at these blue letters above the 0 button where it says catalog. And we're going to go to second 0 for our catalog of everything in this calculator. And we want to skip on down to the D section, which is where we could just click on this x to the -1 button because there's a D above that. So we click that, and this is where we want to look. And we're going to scroll on down until we find something that says diagnostic on. So we're looking for diagnostic on, which is right there. We're going to click on enter, and we're going to click on enter, and it's just going to say done. We have turned our diagnostics on. So again, we go to the catalog, we scroll all the way down to diagnostic on, and then we press enter twice to turn it on. Now we're going to go back to stat, and we're going to calculate a linear regression equation once again. This time, when we calculate the linear regression equation, we won't only have the ax plus b values, but we'll also have now an r squared value and an r value. The r value is what we are concerned about for these two tables. The r value is going to be 0.97, which is really, really strong of a correlation because remember, the highest r value you could have is 1.0. So again, we looked at these points and we saw that they were close together, And we said that it was a strong relationship. And now this proves that it's a strong relationship because we see a very large R value there. 0.97 is very strong of a correlation. So now let's take a look at our second table. And we're going to graph a scatter plot for our second table over here. We have the same X values, if you notice, but now our Y values change a little bit. So we're going to have 2, 1. We're going to have 4, 9. We have 6, 5. And already you could see that these points are a lot more spread out. 8, 2. And finally, we have 9, 8. So again, compared to this chart over here, this scatter plot is all over the place. We don't know if this line is even going up or maybe even going down over here. So let's see how the R value is affected with these points. So again, we want to go to Stat, and we want to edit our lists. We don't have to edit list 1 because we still have the same X values if you look at those two tables. So we just want to clear out list 2 and replace those values with 1, 9, 5, 2, and 8. 1, 9, 5, 2, and 8. And now that we have our list 1 and list 2 values, we want to go to Stat, over to Calculate, and then down to option number 4 for our linear regression. Once our R values are turned on, our diagnostic is on, they should stay on. So now when we go to Calculate, we will have R values here as well. So now you see that the R value is significantly less. We have an R value of a positive 0.27, which is very weak, very, very weak of a relationship. So we have 0.27 for our R value there. And that's an idea of the graph of what a 0.27 correlation looks like compared to an R value of 0.97 in the first part. So if this video was helpful in order to allow you to see the difference between a strong correlation and a weak correlation, give this video a thumbs up to let me know that I helped you out with this topic in Algebra 1. You're now ready for exercise number 3 in the causation versus correlation unit, and you can access that video by clicking on the link right here.